This is a video demonstration of DreamGarden, a design assistant for generating open-ended simulations in Unreal Engine. So the first thing the user does, which we're seeing here, is they'll create a dream node. Here the user's talking about cows being abducted by a spaceship, and they're describing this in quite an open-ended, free-form way. So once the user's satisfied with their dream node, they can begin to step the system. And here what happens is the system has reformulated this initial freeform idea into something a little bit more structured. And then from this high-level description of the simulation, it's broken down a number of high-level implementation steps. And this planning step is applied recursively. Now we're going to let the system run here. Let's now look at what the system did a little bit later. Here it was working on implementing the spaceship and its flight patterns in particular. And so let's compile and run the project as it was at that point in time. So here we are in Unreal. We have a spaceship, and this was a mesh generated via diffusion. And it is moving in the sky, and it is on a flight path into and through the ground. Perhaps not the most reasonable flight path, but it's a start. Now let's jump to the final attempt node that we have in our UI here. And run the project at that point. So here we can see that there are primitives on the ground, which corresponds to the animal actors. And the spaceship is hovering above them, and it does seem to have lifted one of them out of the air. This green debug sphere, though, is kind of an eyesore. So we're going to jump into the code and just comment out that line. In Unreal Engine, we have much the same thing as before, but you see that debug sphere is gone. One thing that's still clearly off, though, is that we're using primitives instead of the cow asset, which you can see the system generated right up there. So here we're going to add a new coding node, and inside of it, we're going to provide some encouraging feedback to the system. And we're going to ask for it to use that cow asset or perhaps the sheep asset. And in order to specify which coding attempt we're responding to, we just drag an edge here from the generated code to our feedback node. And then we'll step the system. Once it's compiled the newly generated code, the system launches in Unreal Engine to run the simulation and collect screenshots for self-evaluation. But here we've stepped in just to check it out ourselves. And we can see the situation on the ground is that the cows are now proper colored and textured meshes. And when we hit play, they are going places with one unlucky cow being lifted into the sky by a spaceship. Let's look at some other ways that the user can interact with the system. And so we've rewound a bit here. And looking at these leaf nodes, we notice that there's one that says generate other animal assets, but then it's marked as a diffusion mesh generation leaf node, which means that only one asset will be generated. But maybe we want sheeps, pigs, and chickens in our simulation ultimately. So let's uncheck this leaf node toggle and then run the system. And we can see that this node, now no longer a leaf, has been broken down into subtasks. And jumping ahead a little bit, we can see that the system has generated those meshes for us for later use. Conversely, if we think of that last user interaction as the user watering a particular part of the tree, forcing it to expand, then the user can also prune the tree. And so just for the sake of demonstration, we've had the system expand this task of generating a chicken asset down into subtasks. And this is something that we noticed happening several times while developing the system, which is that it will do exactly this. Kind of breaking down the task in too much detail. Here it's saying it's going to separately generate a text description, then generate the asset, then import the mesh into Unreal. But as we've seen now, this is all, of course, automated by the pipeline already. And so this node can be a leaf. So we'll check that leaf node. And having resumed the system, we can see that that chicken generation node is once again a leaf. So these are some ways where we allow the user to interact directly with this tree-like graphical representation of its processing. And we noticed in our usability study that users were particularly engaged while watching the growth of the planning tree. And so beyond just pruning or growing the tree, there's a lot of ripe opportunities for allowing users to, for example, edit plan nodes, add or delete them, merge them, or even create a new root plan node that takes input from coding attempts from a previous tree, say, allowing the user to engage in a kind of high-level, long time horizon dialogue in which they push the system to generate increasingly complex and novel simulations.